There is a tunnel beneath New York City that has been running without interruption since 1917. It was built during the final years of World War I. The men who pressurized it for the first time are long dead. The engineering assumptions that governed its concrete lining, what thickness, what aggregate mix, how it would age under continuous hydraulic pressure, are preserved only in documents that predate the existence of the modern computer. And in 108 years of continuous operation, no engineer has ever set foot inside it. Not once. Not for routine inspection. Not for emergency assessment. Not for anything. The tunnel has never been drained, never been visually examined, never had its walls measured for deterioration. The city of New York has been distributing drinking water to more than 8 million people every single day through a piece of infrastructure that no one alive has ever seen from the inside. This is not an oversight. It is not negligence in the conventional sense. There is a specific physical reason the tunnel cannot be inspected, and that reason has been shaping billion-dollar decisions in this city for more than 70 years. I want you to hold one number before we go any further. 6 to 12 hours. Keep it. I'll tell you what it means when the rest of the picture is in place. City Water Tunnel Number 1 opened in 1917. It runs beneath Manhattan and the Bronx, cut through bedrock at depths ranging from 200 to 400 feet, and it carries hundreds of millions of gallons of drinking water every day through a pressurized, gravity-fed system. The pressure comes from elevation. The watershed begins more than 125 miles north of the city, flows through 19 reservoirs in the Catskill Mountains and beyond, and arrives in New York already under pressure from the simple fact that the headlands sit 300 meters higher than the streets of the 5 boroughs. No pumps required. City Water Tunnel Number 2 came online in 1936, constructed as part of the Delaware Aqueduct system. Together, these two tunnels are not a component of New York's water infrastructure. They are the water infrastructure. On a typical day, the combined flow through both tunnels approaches 1 billion gallons. Brooklyn, Queens, the Bronx, Manhattan, Staten Island, every hospital running its sterilization systems, every residential tower with water pressure above the 3rd floor, every fire hydrant that a firefighter will ever connect a hose to, all of it flows through 2 tunnels built before the Second World War and pressurized continuously without pause ever since. The structural problem with inspecting them is not difficult to state. To inspect a pressurized water tunnel, to drain it, walk its length, examine the condition of its lining, measure wall thickness, identify cracks before they propagate into failures. You have to take it offline. You have to stop the water flowing through it. For a tunnel carrying several 100 million gallons per day, that means redirecting that entire volume to other infrastructure. In 1917, when Tunnel Number 1 opened, no other infrastructure existed. The city had 1 distribution tunnel and it was full. And when Tunnel Number 2 came online in 1936, the system still had no redundancy in any meaningful sense. Each tunnel carried roughly half the city's load, and there was nothing else. Taking one offline meant putting the other tunnel under total demand pressure, which it was never designed to sustain, for a population that was already in the millions and growing. The engineers who built these tunnels understood this. It was not a design flaw that went unrecognized. It was a known structural constraint that was documented and handed from one administration to the next. In 1954, 37 years after Tunnel Number 1 first opened, the City of New York formally authorized the construction of a 3rd water tunnel. The explicit stated purpose of the project was this: build a backup capable of absorbing the full water demand of the city so that tunnels number 1 and number 2 can finally be shut down, drained, and inspected for the first time in their operational history. Construction of City Water Tunnel number 3 began in 1970. It is not finished yet. The numbers around tunnel number 3 take a moment to fully register. More than $6 billion spent so far, making it the largest capital construction project in New York City history, larger than any bridge, any stadium, any tower. Over 50 years of active underground excavation by successive waves of workers who in some cases followed their own fathers into the same tunnels. The finished project will stretch more than 60 miles through solid bedrock, running as deep as 500 feet below street level in certain sections. In places, it passes beneath the existing subway network. In others, it passes beneath the foundations of buildings that were themselves built after the Tunnel Number 3 project was already underway. At least 24 workers have lost their lives in construction-related accidents since 1970. The members of Laborers Local 147, the Sandhogs as they are known, have been driving this tunnel across 3 generations of the same union families. The business manager of Local 147, Richard Fitzsimmons, put it plainly in an interview some years ago. They build things that last 100 years. That is the timescale they operate in underground. That is the timescale this project demands. Portions of Tunnel Number 3 opened in 1998, serving Manhattan. Additional sections came online in 2013, but the 2 remaining shafts, Shaft 17B in Long Island City and Shaft 18B in Maspeth, Queens, the ones required to bring Brooklyn and Queens into a fully redundant network, the ones whose completion would finally allow the system to route around Tunnel Number 1 long enough to drain and examine it, are still under construction. Current estimates place completion at 2032. At which point, if everything holds to schedule, City Water Tunnel Number 1 will have been operating without a single internal inspection for 115 years. In the absence of direct inspection, the city monitors the tunnels indirectly. Pressure readings at valve chambers across the 5 boroughs can indicate anomalies in flow behavior. Acoustic sensors can detect certain kinds of structural change. Experienced engineers with decades of system knowledge can read patterns in the data that less experienced staff might miss. This is not guesswork, it is professional inference, and the people doing it are skilled at what they do. But inference is not inspection. Acoustic monitoring does not produce a measurement of concrete wall thickness. Pressure readings do not identify a specific crack location or tell you how far that crack has already propagated. The city is managing infrastructure it cannot see, using tools that were never designed to replace visual examination. For context, the Delaware Aqueduct, an 85-mile tunnel that carries about half of the city's total water supply from the Catskill Reservoir system, had been leaking an estimated 35 million gallons of water per day since the 1990s. The leak had been monitored, documented, and studied for over 20 years before a repair was finally executed. A $2 billion bypass tunnel was constructed. The aqueduct was partially shut down in 2024 for the repair phase. 35 million gallons a day, leaking, known for 2 decades. That is the operational reality of very old water infrastructure at urban scale. Problems develop slowly, get monitored, get deferred, and eventually get addressed, if the system holds long enough for the fix to arrive. The American Society of Civil Engineers grades New York's drinking water infrastructure a C. The city's own mayor's management report classifies the water system's risk in formal language as high consequence, low probability. High consequence, low probability. That is the bureaucratic framing for a scenario where the outcome, if it occurs, is catastrophic, and the probability is judged to be acceptably low. Acceptably low is not zero. Before I get to what a structural failure of tunnel number 1 actually looks like in practice, I want to stop and put a direct question to you. The city identified this inspection problem in 1954. Engineers in the 1970s and 1980s documented it explicitly. A third tunnel was authorized, and construction began for the specific purpose of resolving it. That construction has now been ongoing for 54 years, has cost more than $6 billion, and is currently scheduled for completion in 2032. Do you think that timeline represents a defensible, calculated risk, a city doing the best it could within real constraints of geology, money, and politics? Or do you think it represents something else, a decision to keep moving without resolving a problem that was too large and too expensive to fully confront? I want to know where you come down on that. Tell me below. And if this is the kind of infrastructure reporting you want more of, hit like and subscribe so you don't miss it when the next one goes up. You've been carrying a number since the beginning of this video. Here's what it refers to. 6 to 12 hours. That is the estimated window drawn from engineering analysis of failure scenarios in the New York City water distribution system between a catastrophic structural rupture in City Water Tunnel Number 1 and a citywide water emergency affecting every borough simultaneously. Not days, not a week of gradual degradation, 6 to 12 hours. The physics of a pressurized tunnel failure are not gradual. A significant crack in a century-old concrete lining under the sustained hydraulic load that has been applied since 1917 does not develop slowly and give advance warning. The pressure that has kept the tunnel functional is the same pressure that would accelerate a failure once a structural threshold is crossed. The water does not seep, it moves. The tunnel runs through bedrock at depth. There is no simple surface valve that can quickly isolate a major rupture the way you would shut off a pipe under a sink. Emergency response options are constrained by the geometry of a system that was designed in a different era of engineering for a city a fraction of its current size. What follows in those first hours has a downstream logic. Pressure across the distribution network drops. Buildings that rely on system pressure for fire suppression, hospitals, residential towers, dense commercial blocks across all 5 boroughs lose part of their passive safety redundancy before anyone has made a single decision. Water stops reaching upper floors in buildings without dedicated booster systems. The system shifts to operating on a single tunnel, Tunnel Number 2, built in 1936, whose own interior has equally never been inspected, and which carries the entire primary water supply to Brooklyn and Queens. A review of New York's water infrastructure, conducted in 2021, concluded that if City Tunnel Number 2 were shut down for any reason at all, millions of residents in Brooklyn and Queens would be left without adequate water for 3 full months. That estimate was for a controlled, planned shutdown with advanced preparation. A catastrophic failure is uncontrolled, unplanned, and arrives without preparation time. 3 months for the most densely populated boroughs in the United States. There is no single villain in this story. The sandhogs who have spent careers underground building Tunnel Number 3 have done work of genuine and lasting consequence. The engineers at the Department of Environmental Protection, who manage the existing system with available tools, are not incompetent. The problem was understood, the solution was authorized, the funding was allocated, albeit slowly and inconsistently across different mayoral administrations over 5 decades. The challenge is not that anyone failed to see it clearly. The challenge is that a clear-eyed understanding of the problem coexisted for 70 years with a solution that moved at the pace the geology, budget cycles, political continuity, and the sheer physical difficulty of cutting 60 miles of tunnel through Manhattan bedrock would allow. And the whole time, the original tunnels kept running, because they had no choice but to. The tunnel has been running for 108 years. The workers who stood at valve chambers in the Bronx in 1917 and watched the water move through a system they had spent years carving from rock, they are gone. The engineers who calculated what the concrete would need to withstand under continuous pressure load, gone. The assumptions about material behavior, the specifications, the original construction records, they exist now as archived paper documents from an era when reinforced concrete itself was still a new technology. What remains underground is the tunnel, pressurized, running, unexamined.